I am very pleased to introduce our next speaker, Shophika, who's going to tell us a little bit about modeling in CÉGEP.
So during the pandemic here in Ontario, I basically did a quick search, flattening the curve during the COVID-19. That's something we heard a lot from math folks. We know that we have a little bit of calculus behind that. We have a modeling, but general, citizens, when they think about flattening the curves, they don't have the same reference as us. That's one thing. And the second of all, in Quebec, we had a public health director who would often do these kind of meetings to talk about COVID with the prime minister. And when we do the same research online, we could see Doug Ford just basically doing the same things. So here we have a public health official, and then we have more a political official, and that kind of brought some anger, because sometimes the COVID measures that were put in place, some citizens were thinking that was more of a political thing going on. So as we're seeing lots of polarization, I was kind of trying to think, how could we help folks to figure out what's true according to the reality or the data's? How could they validate things that are often seen in the media? What are the tools that people need? So when we think about COVID, most of the projections were based on math models. And usually you could go on the website of your public health and you have your data and stuff, but that requires somewhat of a basis of mathematics. So in that context, one of the two tools I would say, according to me, would be critical thinking and math modeling to go through these kind of situations. So bringing that, we went then to focus on the context of CÉGEP. CÉGEP is like the 2 years before people choose more scientific tracks in their curriculum courses towards their bachelor's. So in my case, for different reasons, mostly time constraints, I focused on the scientific track. So the 2 years that folks do before going into medicine, nursing, physiotherapy. And I was wondering, what does the curriculum say about critical thinking, mathematical modeling in the mathematics courses? So critical thinking in these programs are often like this thing that students need to have once they get out of their program. But when you go through discipline specific context, it's really hard to find who is really accountable to develop the critical thinking. So when you think about critical thinking, most of the curricula talk about philosophy, French, English literature, and less more about, let's say, I think maybe it's once mentioned in physics, quite surprisingly, but the other scientific disciplines are not really held accountable for that. And for math modeling, interestingly, none of it is quite mentioned in the scientific tracks, but when we go into human sciences, human science tracks who need like math courses, they talk about math modeling. But when you look in the math modeling content, it's often trying to optimize a rectangle. So that's another subject, but that was interesting to see what was actually said about curricula. So moving forward, I had two objectives. Curriculum, the curricula I'm talking about talks about these things for sure. So could mathematical modeling help the math courses? Could math modeling help integrate the math courses into the development of critical thinking skills that the whole program requires? If so, how? That was one of my research objectives. And second of all, since we have the curriculum, the paper, but I mean, the main players of the games are the students, but also the teachers. So I was interested to know, what are these pre-university mathematics teachers' relationship with math modeling? Are they familiar with it? Do they use do they use that in their practice? And what is the underlying perception of mathematics shaping the relationship of math modeling? So the the theoretical tools I use to move forward to the research objectives, I had like two different concepts, a conceptual framework. First of all, I started with the math modeling cycle that my professor France Caron developed. So basically, I'm not going to go through the cycle, but it's the main phases that we go through when we're trying to model a problem. And then there's also the critical thinking. I went to see a framework that was working on the competencies or the skill and the subcompetencies. So as I don't have plenty of minutes, I'll just leave it out there, but I'll be happy to talk about it more in depth. So what I try to do is see which phases require which skills and sub-skills of critical thinking, which led to this. And this is something that was purely theoretical, and moving in the research, I will try to confirm these things. So the conceptual framework, I would say, is I was interested to see what math teachers think about critical thinking as a knowledge, mathematics, and math modeling. So I used the relationship to knowledge concept that was developed by many folks before, but I specifically used the definitions from Thériault. So we have three dimensions. Epistemic is more related to how these things are represented. Identity is how folks see themselves through this knowledge or how they relate to it. And social dimension is everything related to colleagues or the social human aspect of it. So the methodology, I had the chance to work with 8 professors. Very quickly, 3 of them were held a PhD in math. 3 of the other teachers are MScs in math, and 2 of them only had a BSc in math. So the first meeting was more to get a sense of their relationship to knowledge, as mentioned. And the second meeting is we were actually doing a modeling activity with these teachers. I have a couple of resources on the website related to a project we worked on before with my professor. And in the second meeting, we also had a chance to debrief, discuss the challenges and the successes of the modeling processes. So that's a lot of information just being thrown at you. But long story short, could math modeling facilitate critical thinking integration into the math curricula? That was the question. That's why we're trying to talk about these things. So in theory, yes. So the conceptual framework I was mentioning earlier, we were able to validate that. It was not totally perfect because the activities we used, each of the phases were well used and recognized, but some of them, since we used a simulator, some of the phases were really taken by the simulator was dealing with some of the phases rather than the human aspect. So that would be something we would need to explore more. And in practice, that's the most challenging aspect of it, because most of the teachers showed confusion about what actual modeling was. Since we already came with a model, they were not sure if it was a modeling aspect, and that made us realize how many teachers, even though they had studies in mathematics, sometimes never really had the theoretical formation education related to math modeling. So they often saw math modeling as a simple application rather than a process itself and a mathematical activity. So there's also critical thinking. For them, critical thinking, we didn't really give a definition of math modeling and critical thinking because we wanted to understand what teachers had in mind when we were talking about these things. But often critical thinking came up with proofs and rigorous math rather than thinking in context or to try to understand things that are put to us. Most of the teacher also made a link with critical thinking and statistics, but less in, let's say, the type of reflections you would have when you have to solve a problem. The type of is my answer right? Is my answer wrong? What did I do wrong? There's plenty of critical thinking skills that are in place that were not really considered as critical thinking according to the teachers as well. So very quickly, we had if we had to regroup, it's not a generalization. I'll say that in French. We all understand it in English. So we had two types of professor. We had identity-driven that they find modeling pretty cool, nice, but it's not specifically for them because they have a view of mathematics and consider that math modeling is more of an oversimplification of the real thing. And they also mentioned how curriculum was often very overloaded, sometimes very technical and procedural, and they can't really do much to change that because they had students that needed to have the good grades and all the other constraints, we could say. And the other type of teachers we had, it was more epistemic and socially oriented, that they really enjoy seeing how students were interested by seeing how math could be used in a real world context in their jobs and in their fields. But they recognize that they have limited resources. They also were able to recognize that in their initial training, they didn't really do math modeling. So that was very interesting to see how they were open to acknowledge that they maybe didn't have some type of knowledge that was required. So another aspect is, in the context of the study, we used a simulator, that's Insight Maker. It's web-based, so it's pretty easy to use. It's pretty easy to use, but teachers still found that hard to integrate technology in their teaching. And for instance, in the math modeling, I didn't really go into the math aspect that much, but we had differential equation, numerical methods, so Euler's methods, and there was also a way to do discretization. So that's in the math curriculum, but all of these things sounded too complicated for the professors. So they already had a lot of resistance, even though a part of them wanted to. So that was really interesting to see how they felt kind of torn in between. So moving forward, I think there's a lot of things to go into in this field, especially knowing that we have a lot of challenges that we see as citizens, but also as math educators, and what the students expect from us as math educators. So that will be all for my presentation, but I'd be more happy to talk in depth about these things. So thank you so much for listening, and see you soon.